have studied interacting two body system. Interacting two body system reduced to one body problem. Okay, interacting two body system reduced to one body problem. Okay, first number. First, change in total energy. Change in total energy. Okay, total energy. Change in total energy. Change in total energy. Okay, 1 minute. Consider two bodies of masses m1 and m2 at position having radius vector r1 and r2 respectively. Then position vector of position vector of m1 equal to r1 vector, but velocity of m1 equal to r1 derivative of r1 vector. Okay, derivative of r1 vector. Position vector of m2. Position vector of m2 equal to r2 vector. So velocity of m2 equal to r2 vector. Okay, distance between m1 and m2. Distance between m1 and m2 equal to r1 vector minus r2 vector equal to r vector equal to r unit vector r. Okay, the gravitational force of attraction Fr unit vector r between the two masses m1 and m2 is given by, but Fr unit vector r equal to minus g m1 m2 upon r square unit vector r, where Fr function of r unit vector r is the gravitational force of attraction. Gravitational force of attraction. Gravitational force of attraction. Okay, gravitational force of attraction between two masses m1 and m2. Between two masses m1 and m2. Okay, taking magnitude only, we have Fr function of r equal to minus g m1 m2 upon r square. Only magnitude here. Okay, the gravitational potential energy U is therefore given by U equal to gravitational potential energy. The gravitational potential energy. The gravitational potential energy U is therefore given by U equal to minus integration of Fr dr equal to minus integration of minus g m1 m2 upon r square dr. Okay, equal to minus g m1 m2 upon r plus k. Okay, where k is the constant of integration. Integration constant. Okay, integration constant. Okay, for r to infinite, u equal to 0, so k equal equal to 0. Hence U equal to minus G M1 M2 upon R equal to minus G M1 M2 upon R1 vector minus R2 vector. R1 vector minus R2 vector. Okay? Is the gravitational potential energy between two mass points varies universally as the distance between them. Okay? Hence, is that the gravitational potential energy, the gravitational potential energy, the gravitational potential energy between two mass points, between two mass point varies universally as the distance between them. Okay? Hence, total energy of the two body system E2 equal to kinetic energy of M1 plus kinetic energy of M2 plus potential energy of interaction due to gravitational force between them. Hence, total energy of two body system. Hence, total energy of two body system. Hence, total energy of a two body system equal to kinetic energy of masses M1 plus kinetic energy of masses 2 and plus potential energy of interaction, potential energy of interaction due to gravitational force between them. Potential energy of interaction due to gravitational force between them. Due to gravitational force between them. Okay? 1 minute. Then E2 equal to 1 upon 2 M1 R1 derivative of R1 vector whole square in mod plus 1 upon 2 M2 in mod R2 derivative of R2 vector whole square minus G M1 M2 upon R1 vector minus R2 vector. Okay? If we reduce the two body system to equivalent one body system, then if we reduced two body system to an equivalent one body system, then effective reduced mass, then effective reduced mass, then effective reduced mass mu equal to M1 M2 upon M1 plus M2 upon M1 plus M2. Okay? total energy of equivalent one body system E1. Total energy of the equivalent total energy of the equivalent one body system E1 equal to kinetic energy of effective reduced mass, kinetic energy of effective reduced mass plus potential energy of interaction due to gravitational force, potential energy of interaction due to gravitational force, due to gravitational force, okay, due to gravitational force. So E1 equal to 1/2 mu 1 derivative of r vector whole square minus g m1 m2 upon r1 vector minus r2 vector, okay, r1 vector minus r2 vector, okay, equal to 1/2 m1 m2 upon m1 plus m2, okay. The value of mu equal to m1 m2 upon m1 plus m2, okay. Then 1/2 m1 m2 upon m1 plus m2 in bracket are magnitude of derivative of r1 vector minus derivative of r2 vector whole square minus g m1 m2 upon r1 vector minus r2 vector, okay. Because kinetic energy equal to 1/2 mass multiply velocity square, okay. So the mass equal to m1 m2 upon m1 plus m2 reduced mass, and the r1 vector equal to the velocity of derivation of r1 vector equal to velocity of mass m1, and derivative of r2 vector is the velocity of mass m2, and the equivalent is the difference between them, and in whole square. So this is whole square, okay. And we can also write this as this equal to 1/2 m1 m2 upon m1 plus m2, okay. In bracket mod of r1 vector, mod of derivative r1 vector whole square plus mod of derivative r2 vector whole square minus 2r1 vector into r2 derivative of r2 vector minus g m1 m2 upon mod of r1 vector minus r2 vector, because a plus b whole square equal to a minus b whole square equal to a square plus b square minus 2ab, okay. Change in total energy, change in total total energy, changing total energy E1 minus E2 equal to 1 upon 2 M1 M2 upon M1 plus M2. M1 plus M2 in bracket derivative of R1 vector whole square plus mod R2 derivative of R2 vector whole square minus 2 R1 derivative of R1 vector into derivative of R2 vector minus G M1 M2 upon R1 vector minus R2 vector, R1 vector minus R2 vector minus 1 upon 2 M1 R1 vector derivative of R1 vector whole square minus 1 upon 2 M2 R2 vector derivative of R2 vector whole square plus G M1 M2 upon mod of R1 minus R2, mod of R1 minus R2, okay? Okay. Equal to E1 minus E2 equal to 1 upon 2, 1 upon M1 plus M2 in bracket M1 M2 mod of R1 derivative of R1 vector whole square plus M1 M2 M1 M2 mod of R2 derivative of R2 whole square minus 2 M1 M2 in bracket R1 vector R1 vector into R2 vector derivative of R2 vector minus 1 upon 2 1 upon M1 plus M2 M1 plus M2 M1 plus M2 in bracket M1 square R1 vector derivative of R1 vector whole square plus M1 M2 M1 derivative of R1 vector whole square plus M2 square derivative of R2 vector square plus M1 M2 R2 derivative of R2 whole square, bracket is closed, okay, equal to minus 1 upon 2, 1 upon M1 plus M2 in bracket M1 square mod of R1 vector whole square plus M2 square in mod of R2 vector whole square plus 2 M1 M2 in bracket R1 vector into R2 vector, bracket is closed, equal to minus 1 upon 2, 1 upon M1 plus M2 in bracket M1 R1 vector plus M2 R2 vector, bracket is closed, whole square. The position of center of mass of two particle system is given by the position of center of mass. The position of center of mass. The position of center of mass of two particle system is given by vector R equal to M1 R1 vector plus M2 R2 vector upon M1 plus M2. The velocity of center of mass. So velocity of center of mass, velocity of center of mass vector E equal to dr vector upon dt equal to derivative of r vector, okay, derivative of r vector equal to m1 derivative of r1 vector plus m2 derivative of r2 vector upon m1 plus m2. Substituting m1 r1 vector plus m2 r2 vector whole square equal to m1 plus m2 whole square in mod of r derivative of r vector whole square. This is the equation number 3rd. This is the equation number 3rd, and this is the equation number 2nd. This is the equation number 2nd, and this is the equation number this is the equation number 1st. Okay, this is the equation number 1st, and this is the equation number 2nd, and this is the equation number 3rd. Okay, equation number 3rd. Substituting in equation number 3rd, we have E1 minus E2. We have E1 minus E2. E1 minus E2 equal to minus 1 upon 2 m1 plus m2 derivative of capital R whole square. Okay, but 1 upon 2 m1 plus m2 derivative of r vector whole square is the kinetic energy of the center of mass. Is the kinetic energy of the center of mass. Okay, as E1 minus E2 is negative, as E1 minus E2 is negative, E1 minus E2 is negative, the total energy of the system decreases. The total energy of the system decreases by an amount equal to by an amount equal to the kinetic energy of the center of mass. The kinetic energy of the center of mass. Okay, as E1 and E2 is negative, the total energy of the system decreases by amount equal to the kinetic energy of the center of mass. Okay, second, change in angular momentum. Okay, next is change in angular momentum. Okay, change in angular momentum. The angular momentum of the ball system. The angular momentum of the system the angular momentum of the system equal to sum of the angular momentum of the two masses. Sum of the angular momentum, sum of the angular momentum of two masses, okay? So J2 vector equal to R1 vector multiply M1 R1 derivative of R1 plus R2 vector cross M2 derivative of R2 vector, okay? The angular momentum of equivalent one body system. The angular momentum of the equivalent one body system J1 vector equal to R vector class mu R vector derivative of R vector equal to R1 vector minus R2 vector cross M1 M2 upon M1 plus M2 derivative of R1 vector minus derivative of R2 vector, okay, equal to M1 M2 upon M1 plus M2 R1 vector minus R2 vector into derivative of R1 vector minus derivative of R2 vector, okay. This is the equation number 5 and this is the equation number 4. And change in angular momentum. Change in angular momentum, okay. Change in angular momentum. J1 vector minus J2 vector equal to M1 M2 upon M1 plus M2 in bracket R1 vector cross derivative of R vector R1 vector minus R1 vector cross derivative of R2 vector minus R2 vector cross derivative of R1 vector plus R2 vector cross derivative of R2 vector bracket close minus M1 minus in bracket M1 R1 vector cross R1 derivative of R1 plus M2 R2 vector cross derivative of R2 vector whole equal to 1 upon M1 plus M2 in bracket minus M1 M2 R1 vector cross derivative of R2 minus M1 M2 R2 vector cross derivative of R1 vector bracket close plus in bracket M1 M2 upon M1 plus M2 minus M1 into R1 vector cross R1 derivative of R1 vector, okay, plus M1 M2 upon M1 plus M2 minus M2 bracket close R2 vector cross R2 dash vector, okay. So this is equal to 1 upon M1 plus M2 in bracket minus M1 M2 R1 vector cross derivative of R2 vector minus M1 M2 R2 vector cross derivative of R1 vector cross plus m1 m2 minus m1 square minus m1 m2 bracket close r1 vector cross derivative of r1 vector, okay, plus in bracket m1 m2 minus m1 m2 minus m2 square r2 vector cross derivative of r2 vector, bracket is closed, okay. So if we simplify this, okay, then the value is 1 upon m1 plus m2 in bracket minus m1 m2 r1 vector cross r derivative of r2 vector minus m1 m2 r2 vector r2 vector cross derivative of r1 vector minus m1 square r1 vector cross r1 derivative of r1 minus m2 square r2 vector cross derivative of r2 vector, okay. So this value is minus 1 upon m1 plus m2 m1 r1 vector cross m2 derivative of r2 vector plus m2 r2 vector cross m1 r derivative of r1 vector plus m1 r1 vector cross m1 derivative of r1 vector plus m2 r2 vector cross m2 derivative of r2 vector, okay, bracket is closed, whole equal to minus 1 upon m1 plus m2 in bracket m1 r1 vector plus m2 r2 vector cross m1 derivative of r1 vector plus m2 derivative of r2 vector, okay, bracket close and whole bracket close. This is the equation number 6. The angular momentum of center of mass is given by the angular momentum of center of mass is given by the angular momentum of center of mass is given by r1 is given by vector r cross m1 plus m2 derivative of r vector, but vector r equal to m1 r1 vector plus m2 r2 vector upon m1 plus m2 and derivative of r vector equal to m1 derivative of r1 vector plus m2 derivative of r2 vector upon m1 plus m2. Angular momentum of center of mass. Angular momentum of center of mass equal to m1 r1 vector plus m2 r2 vector upon m1 plus m2 cross m1 plus m2 into m1 r1 derivative of r1 plus m2 derivative of r2 vector whole upon m1 plus m2 equal to 1 upon m1 plus m2 in bracket m1 r1 vector plus m2 r2 vector cross m1 derivative of r1 vector plus m2 derivative of r2 vector. Derivative of r2 vector. This is the equation number 7. Comparing 6 and 7. Comparing 6 and 7. Okay. Comparing the equation 6 and 7. That angular momentum of the system angular momentum of the decreases by an amount equal to the angular momentum of the center of mass. Okay, thank you. And next heading is rocket.